So once you've installed Abaqus, open it up, select the with standard / explicit model option, and we'll get started with the modeling. So the first thing you do is right-click part, hit create, and call your part cylinder, which takes me a little bit to spell. But once you've named your part cylinder, everything else can be left as default, and just press continue, which will pull up the next screen, which is a sketch screen. Grab circle, drop 1 point at the origin, and set the circle to be however big you want. Grab the dimension tool, and then dimension it to have a radius of 5 units. Now that you've done that, exit the dimension tool, press done at the bottom to exit the sketch tool. Now you're in the extrusion pop-up, so set your depth to 10, press OK. The next thing we're going to do is we're going to define a material. So head on to material in the tree, right-click create, and call it aluminum. Enter in the mass density under general properties and Young's modulus and Poisson's ratio under mechanical elasticity as outlined in the lab manual. Now that we're done that, we're going to create a new section. So right-click on the section item in the model tree and click create to name a new homogeneous section. Leave everything as is, press OK again. Now we're going to click the assign section button, grab our cylinder, and press done at the bottom. And now we've assigned our cylinder to be made of aluminum. This is all good, so press OK. Now it should turn green. Now we're going to create an instance. So right-click on instances under assembly and press create. Make sure the cylinder part that you just created is selected. It should be. Press independent and hit OK. Now go into tools in the top toolbar. I just rotated around a little bit, but go into tools and then reference point, and then click on the origin, and now you've set the origin as reference point 1. Now right-click on steps in the model tree to create a new step, and call your step loading. Make sure the static general type is selected, and press continue. Call the description loads applied, leave everything else as default, and click OK. Next thing we're going to do is we're going to create the mesh. So go into the module dropdown and select mesh. Select the partition face sketch tool, which is on the left toolbar, after you rotate the cylinder around. So select the partition face sketch tool and select the face that is not the face with the origin on. Press done at the bottom, and then select the circle that encompasses the face you just selected. Now you're going to sketch again, so grab the line tool and draw 2 lines that cut your circle in half and go through the origin. Press escape between drawing the lines to start the next line. Once you're done, press done, and you should have the cross on the face of your cylinder. Select the seed part instant tool at the top of the toolbar and enter in 1.5 for approximate global size, and press OK. Nothing else in that one matters. Press done. Now go up to the mesh part instant tool, which is right there, and select yes, and now we've meshed our cylinder. Find the query tool in the top, select mesh in the box that pops up, and select done in the bottom, and that will tell you how many nodes there are in your cylinder. Make sure you just write this down somewhere, and don't worry if you don't have the exact same number of nodes as I do. Now you're going to create a new constraint, so exit this toolbox and click the constraints item, right-click it in the model tree, and press create. Choose the coupling type of constraint and call your constraint couple. Click continue. Select the reference point you made earlier, which will highlight orange when it's selected. Uncheck create set, press done. Press the surface option when you're asked for a constraint type. It should be the default one. And select the face of the cylinder where the reference point is defined. So not the cylinder with the side with the cross on it. And press done once you've selected it. And then press OK in the box that pops up. It should all be the same as the default. So press OK. And now we can define our loading conditions. So right-click on the loads item in the model tree and press create. So go to the model tree, right-click loads, press create. Call your load N and V, and choose concentrated force mechanical. So that should be default, so no worries about that. So you can leave everything as is in this box other than the renaming it. And then press continue. It'll ask you select a point, so select the reference point, making sure create set option is unchecked, it should be, and then press done. So here you're going to calculate the normal and shear forces that you calculated in the pre-lab exercise in these boxes. I won't be sharing mine, but just keep in mind units, and that CF1 corresponds to forces in the x-axis, CF2 corresponds to forces in the y-axis, and CF3 corresponds to forces in the z-axis. Again, making sure you're paying attention to the units that you're inputting the force in and the orientation. So you can put a negative in it if you want it to be down, and if you don't want to fill in a force in a certain box, you can leave it blank or you can type in 0. So once you're done that, press OK. Create another load, press create, call it torque and bending, and this time select moment instead of concentrated force, and press continue. And just as before, I won't share my values, but type in the torque and oh, sorry, I missed I missed something. You can just select whatever face you want as the torque is all uniform. And just as before, type in the values you got in the pre-lab and make sure all the units are consistent. CM1 refers to torque in the x-axis, CM2 refers to torque and moment in the y-axis, and CM3 refers to torque and moment in the z-axis. Once you've done that, press OK. And now we're going to create a new boundary condition. So click the Create Boundary Condition icon in the toolbar. And we're going to leave this as is. So mechanical, change loading to initial, leave mechanical and select it as is, and pick any one of your pizza slices, any one of the corners of your cylinder. At the bottom, select Done. Once you've selected a quarter of your cylinder, and select the bottom option here. So we'll select Ncaster, U1 equals U2, and so on and so forth. Press OK. So now we've immobilized that face. We've said that part can't move. And we're going to do it again for each of the corners. So press Create Boundary Condition, leave it as is, press Continue, grab one of your corners, any one of them, it does not matter what order you do it in, press Done, and select the bottom option. Do it twice more. Select the face, select the bottom option, create boundary condition, continue, select the face, select the bottom option, and now we've immobilized this entire surface. Its entire surface is fixed. So now we're ready to run a simulation. So under Analysis, right-click Jobs and press Create. Make sure your model is selected. It should be. You don't need to name it anything other than Job 1. So you're fine to press Continue. Give your job a description if you want. Don't stress too much about this. It doesn't matter a ton. And then leave everything else here as default and press OK. Now press the Job Manager, which is the top right computer thingy on your toolbar, and press Submit. So now we're going to send our job to be run. No worries if you get a weird pop-up. So no worries if you get this weird pop-up. You're fine to overwrite them. Reminder to save your model, by the way. I forgot, but reminder to save your model. In the bottom, we can see that our job was running and was completed successfully. Super exciting. So now to see it, we're going to go to the jobs in the toolbar, expand it, see job 1, right-click it, press Results, and this is our FEA analysis. So ours was a little funky. No worries if yours doesn't look like ours. This is a first iteration of ours. I went back and I changed the forces a little bit, so here's a speed run of that. And eventually it looked like this, which makes a lot more sense. And now that we're in this phase, this is where you'll be doing most of the generating graphs, changing what's plotted, changing what looks like what, which you should be able to do by following the procedure or just poking around a little bit. But yeah, so now you've modeled a cylinder with the torque and moment and shear and normal forces applied to it, and you're seeing kind of how it's going to deform and what parts will be under the most stress. Feel free to DM me if you have any questions or any problems. Yay!